Welcome to the Graph Algorithm playlist. Hello. Now, in the last video, we discussed about spanning trees, and I basically introduced you to the concept of what it means to span a graph. But this is just a short add-on video, and it's just to give you an example of spanning trees and how do we find them. And this will finally lead us, this will finally bring us closer to the topic of minimum cost spanning trees and the algorithms related to it. So we are just here going to discuss about the example in this short video. Now take this example. We want to span this graph with minimum number of edges. Basically, we want to span this graph with a spanning tree. We want to find a spanning tree here. And this is fairly simple. I can give you a simple run, let's say 1 to 2, 2 to 4, 4 to 3, 3 to 5. And this is a spanning tree. We found a spanning tree here. But let's say we want to do it a little bit systematically. So we first, as spanning trees don't contain cycles, we first remove what the edge 2, 3 to reduce the cycles from 2 to 1. But still there is a cycle here, and so simply we can remove the edge 2, 4, and we got a spanning tree here. We could have removed 4, 3, 3, 5, or 5, 1, or 1, 2 also, and we will get different spanning trees. So that means there is not a unique spanning tree for any graph. So you can see that this simple graph gave us these many spanning trees, and in fact there are more spanning trees left here. I'm only showing you these, but there are more spanning trees left here. So spanning trees are not unique, you know, for any graph. There's not just a single spanning tree for a graph. There can be many, and we actually missed some spanning trees here as we initially removed the edge 2, 3. But what if we didn't remove it? Then we need to remove one of 2, 4 or 4, 3 to break the cycle X, and one of 2, 1, 5, 1, 5 and 5, 3 to break cycle Z, and we'll get different spanning trees. So that means that spanning trees are not unique, or there's not a single spanning tree for every graph. There can be many, and and from this particular fact, we arrive on to this particular fact leads us to the concept of minimum cost spanning trees, because when these edges get weights, here these edges don't have weights. That's why it does not matter, but it matters in the case where edges get weights, and now spanning trees become different, because every other spanning tree has a cost of its own, and we can now arrive on to different optimization problems with the maximum cost, with the minimum cost, or some kind of shortest path to span something, etc. All those kind of things. Now this is just the video. That's it for this video. We'll meet in the next video to discuss the algorithms which are related with the spanning trees and the weighted edges in a graph, and then we find spanning trees. So that's it for this one. Let's meet in the next one, and until then, peace out.